Right now, 12 billion miles from Earth, a tiny metal box built with the same simple technology as a 1970s car radio is floating through a pitch-black ocean of cosmic radiation. While everyone on Earth goes about their daily life, this small probe is picking up a strange, continuous radio hum that scientists never predicted. It is sending back coded numbers through the dark, telling us that the space beyond our solar system is not quiet at all. Something out there is buzzing with invisible energy, and our lonely spacecraft is the only eye we have watching it happen. If you love exploring the real mysteries of our universe without any fake drama, take a moment to subscribe right now. By joining our community of curious thinkers, you will always be the first to hear about incredible discoveries happening at the very edge of human knowledge. To understand why this distant message is so surprising, we have to travel back in time to the summer of 1977. That was the year NASA launched a pair of robotic space probes called Voyager 1 and Voyager 2 from Cape Canaveral in Florida. Scientists had noticed a rare pattern in how the giant outer planets lined up in space. This special alignment only happens once every 176 years. It meant that a single spacecraft could fly past Jupiter, Saturn, Uranus, and Neptune by using the gravity of each planet to boost its speed to the next one. When engineers at the Jet Propulsion Laboratory built Voyager 2, they were not expecting it to last very long. The original mission was only supposed to last 5 years, just long enough to take pictures of Jupiter and Saturn. The technology on board was very basic compared to what we have today. And the main computer on Voyager 2 has less processing power than a modern key fob used to unlock a car door. Its data was stored on an old-fashioned 8-track digital tape recorder. Despite these simple parts, the engineers made the probe tough enough to survive the harsh cold of space. They gave it a large dish antenna 3.7 meters wide to send signals back home. To keep it running far away from the bright light of the sun, they equipped it with 3 nuclear generators powered by decaying plutonium. And these generators provided about 470 watts of power at launch, which is about the same amount of electricity needed to run a few regular household light bulbs. Voyager 2 took off on August 20th, 1977, actually launching 16 days before its twin probe, Voyager 1. Its path was carefully calculated so that it could visit all 4 giant gas planets in the outer solar system. No other spacecraft in human history had ever tried to visit 4 major planets on a single trip. It was a giant leap into the unknown carried out by a machine built with wires, aluminum, and simple computer chips. As Voyager 2 raced away from Earth, it moved at speeds over 34,000 miles per hour relative to the Sun. It reached Jupiter in July of 1979, giving humans their very first close-up look at the Great Red Spot and the icy moons orbiting the giant planet. Scientists were shocked to see active volcanoes spurting sulfur on the moon Io, proving that distant moons were not just cold, dead rocks. 2 years later, in August of 1981, Voyager 2 arrived at Saturn. It sailed past the famous glowing rings, snapping thousands of detailed photos and studying the planet's thick atmosphere. After completing its mission at Saturn, the probe did something no other spacecraft had done before. It used Saturn's gravity like a cosmic slingshot to hurl itself toward the mysterious ice giant Uranus, pushing deeper into the outer solar system. In January of 1986, Voyager 2 made history by becoming the first human object to fly past Uranus. It discovered 10 new moons and a strange tilt in the planet's magnetic field that completely puzzled astronomers. Then, in August of 1989, it reached Neptune, discovering 5 new moons, active geysers on the moon Triton, and a giant storm system known as the Great Dark Spot. After passing Neptune, Voyager 2 had finished its original job of exploring the planets, but instead of shutting down, the probe kept flying outward at incredible speeds. It was heading down toward the southern side of our solar system, traveling into uncharted territory where no human vessel had ever drifted before. Scientists realized that if the spacecraft could keep its systems warm, it might survive long enough to reach the boundary where our sun's power finally fades away. Did you know that Voyager 2 is the only spacecraft in human history to visit all 4 giant outer planets up close? Drop a comment below if you remember learning about its famous planet flybys, and hit the like button if you think this old machine is one of humanity's greatest achievements. For decades after leaving Neptune behind, Voyager 2 traveled through a massive region of space dominated by our sun. Scientists call this giant bubble of space the heliosphere. The sun is constantly blowing out a wind of superheated particles called plasma that travels millions of miles per hour in every direction. And this solar wind creates a huge protective shield around all the planets, keeping out dangerous cosmic rays that fly through the deeper galaxy. As long as Voyager 2 was inside the heliosphere, the instruments on board picked up steady streams of solar particles and steady magnetic fields. Scientists on Earth expected that as the spacecraft traveled farther from the sun, space would simply get emptier and quieter. The prevailing theory was that the boundary between our sun's domain and interstellar space would be a smooth, gentle drift into absolute nothingness. Here's the detail most people never notice about deep space exploration. Scientists assumed that once Voyager 2 got far enough away from the sun, the particle density would drop to nearly zero. They pictured interstellar space as an empty, peaceful void waiting quietly beyond the planets. But when Voyager 2 finally reached the edge of the solar system, what it actually detected was completely different from what anyone had written in the textbooks. On November 5th, 2018, at a distance of nearly 11.2 billion miles from the Sun, Voyager 2 crossed the outer border of the heliosphere. This boundary line is known as the heliopause. The instant the probe crossed this invisible line, its plasma science instrument registered a sharp drop in solar particles. But instead of space becoming empty, the spacecraft was suddenly hit by a thick wall of interstellar plasma. The density of particles around the probe did not go down at all. Instead, the density jumped up by a factor of 20. Space outside our solar system was actually much denser, hotter, and more active than the space inside our sun's protective bubble. The spacecraft was moving through a compressed layer of interstellar material that acted almost like a physical wall surrounding our entire solar system. Scientists realized that the solar wind pushing outward hits the gas of interstellar space pushing inward, creating a turbulent boundary zone. The sun's bubble is actually carving out a hollow pocket inside a dense cloud of cosmic gas. Crossing this boundary meant Voyager 2 was officially moving through the interstellar medium, the huge space between the stars. It became only the second human-made object in history to enter interstellar space following its twin Voyager 1. And even though Voyager 2 crossed into the interstellar medium, it is important to understand that it has not yet left the solar system itself. The outer edge of our solar system is defined by the Oort cloud, a giant spherical shell of icy comets kept in place by the sun's gravity. NASA estimates it will take another 300 years for Voyager 2 to reach the inner edge of the Oort cloud. Crossing through it completely could take as long as 30,000 years. What made the boundary crossing so dramatic was the noise picked up by Voyager 2's instruments. The spacecraft carries a special tool called the Plasma Wave Subsystem, designed by researchers at the University of Iowa. This instrument does not record sound waves like a microphone because sound cannot travel through the vacuum of space. Instead, it measures electric waves traveling through the charged plasma gas floating between the stars. When scientists converted these electric measurements into audio frequencies that human ears can hear, they did not hear silence. They heard an eerie rising whistle followed by a steady low hum. It sounded like an alien wind howling around the spacecraft as it pushed deeper into the dark. This unexpected noise was proof that interstellar space was vibrating with high-frequency plasma waves caused by massive events happening elsewhere in the galaxy. Have you ever wondered what space actually sounds like beyond the reach of our sun? Leave a comment with your thoughts on these eerie space sounds, and don't forget to subscribe to stay updated on all our deep space stories. The strange signals picked up by Voyager 2 are not the only unsettling events in its long journey. Over the years, the spacecraft has experienced bizarre glitches that left flight control engineers at NASA scratching their heads. One of the most famous incidents happened in April of 2010, when Voyager 2 was roughly 8.6 billion miles from Earth. Without any warning, the data coming back from Voyager 2 suddenly turned into complete nonsense. The engineering systems on the probe were working perfectly, and the radio signal was strong, but the scientific information was scrambled. It was as if the spacecraft had suddenly started speaking an unknown language. Scientists could tell the probe was trying to transmit its normal readings, but the binary code of zeros and ones was shuffled out of order. For weeks, team members at the Jet Propulsion Laboratory worked around the clock to figure out what was happening. They suspected that cosmic rays hitting the onboard memory might have flipped a single bit of computer code. After running tests on twin computers on Earth, they discovered that a single memory location in the flight data system had indeed changed from a 0 to a 1. This tiny flip in a single memory cell had rewritten the software instructions that packaged scientific data before sending it to Earth. Engineers had to carefully beam a software patch across billions of miles to fix the single flipped bit. It took 13 hours for the radio command to reach the probe at the speed of light and another 13 hours for the confirmation to travel back. And to everyone's relief, the fix worked and Voyager 2 went back to sending clear data. Another terrifying moment occurred in late July of 2023. Flight controllers accidentally sent a routine command that caused Voyager 2's main dish antenna to tilt just 2 degrees away from Earth. That tiny 2-degree shift was enough to completely miss our planet. The dish was no longer pointed at Earth's receiving stations, cutting off all communication in an instant. For several days, NASA heard nothing from the distant probe. The team was faced with the frightening possibility that their far-flung explorer might be lost forever in the dark. Because Voyager 2 was over 12 billion miles away, even a microscopic mistake in antenna alignment meant its narrow beam of radio waves was shooting off into empty space, missing Earth by millions of miles. To fix the problem, NASA turned to the Canberra Deep Space Communication Complex in Australia, and this facility features a giant 70-meter radio dish known as Deep Space Station 43. It is the only dish on Earth powerful enough to transmit signals capable of reaching Voyager 2 in its southern trajectory. Scientists used this giant dish to perform a routine scan of the sky, searching for any faint sign of life from the missing probe. On August 1st, 2023, the Canberra dish picked up what scientists called a heartbeat signal. It was a faint carrier wave indicating that Voyager 2 was still powered on and broadcasting its radio tone. However, the signal was too weak to carry any actual data because the antenna was still pointed slightly away from Earth. Knowing the probe was alive, controllers decided to try a risky maneuver called an interstellar shout. They used the massive Canberra transmitter to beam a high-powered voice command directly at Voyager 2, ordering it to reorient its dish back toward Earth. The command had to travel for more than 18 hours across 12 billion miles of space. On August 4th, 2023, NASA received confirmation that the command worked. Voyager 2 turned its dish back home, restoring full scientific communications. Does it amaze you that engineers can fix a computer glitch on a spacecraft 12 billion miles away using a radio signal? Type your reaction in the comments section below and give this video a like if you find deep space engineering fascinating. Now that communications are fully restored, scientists are carefully examining the continuous signals Voyager 2 sends back from the interstellar medium. The data shows that the environment outside our solar system is far more complex than anyone predicted. One of the biggest surprises is the behavior of the interstellar magnetic field. Before Voyager 2 crossed the boundary, theoretical models suggested that the magnetic field outside our solar system would be tilted in a completely different direction than the Sun's magnetic field. Scientists expected Voyager 2 to register a sharp change in the direction of magnetic lines as soon as it stepped out of the heliosphere. And that directional shift was supposed to be the definitive proof that the probe was out in true galaxy space. And what Voyager 2 actually discovered blew those theoretical models apart. When the probe crossed the boundary, the direction of the magnetic field did not change at all. The interstellar magnetic field was running parallel to the magnetic field inside our solar system. And this unexpected alignment left astrophysicists stunned, forcing them to completely rethink how our sun's magnetic bubble interacts with the surrounding galactic environment. Another strange finding involves the temperature of the interstellar plasma. Scientists expected the gas between the stars to be extremely cold, hovering near absolute zero. While the overall density of the plasma is very low, the temperature of the ionized gas measured by Voyager 2 is actually thousands of degrees hotter than predicted. It turns out that high-energy cosmic rays blowing through the galaxy keep this thin interstellar gas in a perpetually heated state. In addition to heat, Voyager 2 detected a continuous low-level hum in the interstellar medium. This radio noise is caused by plasma oscillations, small waves of electric charge bouncing through the thin gas. Unlike sudden bursts of energy coming from distant exploding stars, this hum is steady and unending. It is like the background noise of interstellar space itself, a gentle cosmic chorus that never turns off. Scientists at the Jet Propulsion Laboratory describe this background noise as a persistent interstellar rain. And the plasma wave receiver on Voyager 2 records these faint vibrations constantly, allowing researchers to measure the density of space gas even when no major solar storms are passing by. The readings show that interstellar space is filled with subtle pressure waves ripple through the cosmos like waves on an endless ocean. Every bit of information Voyager 2 sends back is precious because no other active probe is currently exploring this region. Its twin, Voyager 1, is also in interstellar space, but its plasma instrument failed decades ago. That makes Voyager 2 our only working eye capable of directly measuring the density, temperature, and electric activity of interstellar gas. Every reading it takes is a historical first for human science. As Voyager 2 pushes deeper into this alien region, scientists are keeping a close eye on its declining power supply. The spacecraft is powered by radioisotope thermoelectric generators, which convert the heat released by decaying plutonium-238 into electrical power. But plutonium decays over time, losing about 4 watts of power every single year. After almost 5 decades in flight, Voyager 2's power levels have dropped by more than half. The probe currently operates on barely 200 watts of power. That is barely enough energy to run a couple of small household appliances. To keep the critical science instruments running, NASA engineers have had to make tough decisions, turning off non-essential systems one by one to save precious electricity. If you could send a message to a spacecraft floating 12 billion miles from Earth, what would you say to it? Let us know in the comments below and consider subscribing to stay connected with our ongoing space discoveries. Over the last decade, engineers at the Jet Propulsion Laboratory have used clever strategies to extend Voyager 2's lifespan. They turned off heaters that kept scientific instruments warm, forcing the instruments to operate at freezing temperatures far below what they were originally tested for. Miraculously, instruments like the cosmic ray detector and plasma sensor kept working perfectly even in the extreme cold. In 2023, NASA implemented a bold new power strategy for Voyager 2. They decided to tap into a small reserve of backup power that was originally set aside for a safety mechanism designed to protect the spacecraft from voltage spikes. By shutting off this safety switch, engineers freed up a small amount of extra power, allowing all 5 remaining science instruments to keep running for another 2 years. This clever hack bought vital time for scientists who want to collect as much interstellar data as possible. However, the laws of physics cannot be cheated forever. The radioactive plutonium inside Voyager 2's generators will continue to decay day after day. Eventually, the power output will drop below the absolute minimum level required to keep even a single science instrument turned on. Current estimates suggest that NASA will likely have to turn off Voyager 2's science instruments one by one over the next few years. By around 2030, the spacecraft will no longer have enough power to run any of its scientific equipment. At that point, the primary interstellar science mission will come to an end, closing a glorious chapter in space exploration history. Even after its scientific instruments go dark, Voyager 2 will continue to send a basic radio carrier signal as long as its main computer can draw power. But eventually, around 35 years from now, the power will fall too low to operate the transmitter at all. The lonely probe will finally go completely silent, ending all communication with Earth forever. Yet going silent will not be the end of Voyager 2's epic journey. In the vacuum of deep space, where there is no air, no water, and no friction, object motion lasts virtually forever. Voyager 2 will keep coasting through the Milky Way galaxy at a speed of over 34,000 miles per hour, drifting along an endless cosmic path. In about 40,000 years, Voyager 2 will pass within 1.6 light-years of a small star called Ross 248. located in the constellation of Andromeda. Millions of years from now, long after the cities on Earth have changed or faded, Voyager 2 will still be sailing through the stars, carrying a physical record of the civilization that created it. That physical record is the famous Golden Record, a gold-plated copper phonograph record mounted to the exterior of the spacecraft. The record was designed by a committee led by famous astronomer Carl Sagan. It contains a curated selection of Earth sounds, images, and cultural achievements meant as a time capsule for any intelligent alien life that might discover the probe in the distant future. What do you think is the most important item carried on the Golden Record for an alien civilization to find? Share your opinion in the comments below and subscribe if you want to see more deep dives into space mysteries. The Golden Record carried on Voyager 2 contains 115 images showing life on Earth, including diagrams of human anatomy, pictures of landscapes, and drawings of scientific concepts. It includes spoken greetings in 55 human languages, starting with an ancient Akkadian greeting and ending with a message from a modern child. It also contains a rich collection of music from different cultures and eras, featuring pieces by Bach, Beethoven, and Mozart, alongside traditional folk music from around the world and Chuck Berry's famous rock song, Johnny B. Good. It carries natural sounds of Earth, such as the sound of wind, rain, thunder, bird songs, whale calls, heartbeat rhythms, and footsteps. To ensure any intelligent species that finds the record can play it, NASA included a stylus and clear visual instructions engraved on a protective aluminum cover. The cover also features a map showing the location of our sun relative to 14 distant pulsars, allowing anyone who understands physics to pinpoint exact coordinates of Earth in time and space. The cover of the Golden Record is coated with a pure sample of uranium-238. Because uranium-238 decays at an extremely steady rate with a half-life of 4.5 billion years, an alien scientist who finds the probe can measure the remaining uranium to calculate exactly how many billions of years ago the record was launched from Earth. This makes Voyager 2 more than just a scientific probe. It is a drifting message in a bottle floating across an ocean of space and time. It represents humanity's eternal desire to reach out into the unknown, to explore beyond our immediate horizon, and to leave a lasting mark on the vast cosmos. Right now, in 2026, Voyager 2 is continuing its solitary march into the dark. Every single second, it moves another 10 miles deeper into interstellar space. Every day, the faint radio signals carrying its readings travel for 18 hours at the speed of light before reaching the giant listening dishes of the Deep Space Network on Earth. The strange signals and plasma hums recorded by Voyager 2 have shown us that the space beyond our solar system is a living, dynamic realm full of unknown forces. It has challenged what we thought we knew about magnetic fields, particle densities, and cosmic boundaries. It has reminded us how small our planetary home really is compared to the vast galactic environment surrounding us. As we watch Voyager 2 complete its final years of active operations, we are witnessing the closing moments of humanity's very first physical foray into interstellar space, the little probe that could have far exceeded every expectation, surviving 5 decades in the harshest environment known to science and changing our understanding of the universe forever. When Voyager 2 finally goes quiet, it will leave behind a legacy that will inspire generations of future explorers. The data it collected will be studied by scientists for decades to come, helping us design future missions that will one day follow its path beyond the stars. If you enjoyed this deep dive into the mystery of Voyager 2 and its strange interstellar signals, please hit the subscribe button right now and turn on all notifications so you never miss a new video. Leave a comment below answering this question. Do you think humanity will send new probes to interstellar space before the end of this century? Share this video with a friend or family member who loves space and science, and help us share these amazing stories with more curious minds around the world. Thank you so much for watching, and stay curious until next time.